This is the article that I chose to analyze, and it's headlined US Bows to South Korean BSE Fears. So it's basically about South Korea halting its imports of American beef because South Koreans fear of the mad cow's disease and especially the safety of the beef. The effect of this decision is a shift in the supply curve of American beef. This would account for a supply shift left mainly due to a shock supply shifter, because this is due to an unexpected turn of events. As a result, the importation of US beef has slowed down, but the demand stays the same, so the price is increased. Now we're going to take a look at the supply and demand curve, and here it is. Move it up a little bit. And so the supply of American beef, as you can tell, is rather inelastic, and that is because beef is produced in seasons, and it does take time to breed and raise cows ready for slaughter and ready to be sold. And so we can see that represented in a steeper slant in this supply curve. On the other hand, the demand curve is rather elastic, as you can see here, because there are many substitutes for American beef, such as local beef, chicken, other brands of beef, and that is represented with this less slanted line here. As I've mentioned before, the supply curve would have shifted left as a result of the halted importation of American beef. So let me change it here real quick. The new graph, the new supply curve, would look something like this. Will be something around here. And I'll talk more about it later, but I'm just gonna put it there for reference. Put it right there to show a shift to the left. And now I'm gonna talk more about this table here. So I created a table with several prices and the quantity demanded here and the quantity supplied here. And these are just thousands of kilos of American beef. And now I'm going to show you how I came up with the two equations for these two lines. So we know that a linear graph, a linear line has the equation of y equals mx plus b, and that's what I have here, except it's quantity demanded equals a minus bp. So now I'm going to show you how I figured it out for this graph here, right here. I'm going to take this, I have it here. So first I'm going to look for what B is, and B equals the change in quantity demanded over the change in price. I'm going to take these two values here because this is going to be my price initial, P1, and this is going to be my P2. So I took my quantity for the first one, 10, and I subtracted that by 15, which is the second quantity. Then I divided that by the change in price. So 10 was associated with $40. So 40 minus 20, and I got 20. So 10 minus 15 is -5, and 40 minus 20 is 20. So -5 over 20 got me -1/4. Then after that, I used that number to figure out what A stand for. I plugged in just another point from the gram by random point. So I took this one, $20 for 15,000 kilos of American beef, and I plugged it in, and I got A equals 20. With these two variables in mind, I could figure out my final equation. which is quantity demanded equals 20 minus 1/4 P. So if I plug in any price into this equation, I can figure out a quantity demanded. And that's how I figured out this orange line right here, orange linear line. So now we're going to take a look at the supply equation, and it is very similar to the demand equation, except for the fact that it is addition instead of subtraction. So first we start off with looking for what D stands for, and that is change in quantity supplied instead of demanded over change in price. And so once again, I took the same set of numbers from here. And so that would be the first price, 16 minus 14 right here, divided by 40 minus 20. And that would be 2 over 10, which is simplified to 1/10. So then now that I have D, I plug that into the equation to find C. So I just chose once again a random set of numbers from my table here. And I used $40 and 16,000 kilos of American beef. And once I plugged that in, I got C equals 12. With these two variables similar to the demand equation, I can figure out my final supply equation, and that is I have a mistake here. Quantity supplied. So as a result, the quantity supplied equals 12 plus 1/10 P. And if I plugged in any number for price, I get this equation right here, this line right here. So now let's talk about how we found out the equilibrium price and quantity. And that is this point right here. This is where the two lines intersect. And so the equation for that is setting these two equations equal to each other. And that's what I did here. And if do system of equations, we do system of equations, I get this number right here. 160 over 7, which is approximately 22.8. And if we look here and we just move that down, follow that down, it hits about 22.8. This is the point that tells us the number that would be most efficient for the sellers to use, because this is the place where the sellers can ensure that there wouldn't be any surplus on the shelves, there wouldn't be any surplus in the storage, because the amount of supply that they provide is the amount that the customers demand. And now coming back to this new graph after the shift, this would be the new point of equilibrium right here, where these two graphs now intersect. And as you can see, at this point of equilibrium, the price is higher, as I've mentioned before, that the price would be increased with lower supply. And the quantity demanded is also lower, as you can see here. So as a result, we can tell that a shift in supply is directly related to a shift in the equilibrium point. Thank you.